Okay, here we come.
Okay.
Joe, I think we've connected, gentlemen. Once again, stargazers, let's talk cutting edge cosmology here on the weekly SBAU Astro Hour. It's a Monday morning blog podcast we've been doing over 2 years, into our third year now for the South Coast Longtime Telescope and Astrophysics Club, the Santa Barbara Astronomical Unit. Proud to be your host, as well as Vice President Ron Herron. We're based at the Santa Barbara Museum of Natural History, for now still in the back down below next to the creek in that incredible Farron Hall. We may be moving, though, you never know. Following the reopening after the pandemic winds down, we've had some big crowds and good speakers, and coming up on June 2nd will be Professor Ski Antonucci of University of California, Santa Barbara, taking us way out to the edge of the universe and visiting quasars. Here's what we're going to talk about today, everybody. It's cutting edge stuff involving, a close look at Fomalhaut. I believe I pronounced it right. Is that right, Fomalhaut?
Good enough.
In Pisces. We got star clusters everywhere. We get more star clusters than variable stars anymore. This time it'll be 2 of them. Damn. Sends in these things it wants me to buy on the bottom of my screen. Perseverance found a previous rubber bed on Mars, and we got more Mars news. I think it's going into Ophiuchus. No, that's a different title. What's inside the moon? We'll find out. We'll get that covered. And this is fascinating. I can't wait to hear Jerry talk about it. Why is there possibly no planet life, no life on planets, or very few anyway? They calculate, even though they don't know, they haven't found any out there in our galaxy specifically, as well as the thing we talked about, a mystery solved, the runaway black holes. That was a couple weeks ago on our Astro Hour. This is number 117 for May 15th through the 21st. Let's meet the gang. President Jerry Wilson, hanging in there. Good morning, sir.
Good morning.
His wife, I'm sure, yesterday, Pat Forgy, on Mother's Day. We'll take it as they joined us. On my screen to the right of me is the president himself of the Santa Barbara Theater Organ Society, Bruce Murdoch, one of our longtime active members. Bruce.
Hello.
Mary, I assume you're a parent as well, and so Mom's Day went to Bonnie, your wife, yesterday.
Yeah, my mother would be, I don't know, 109 years old now.
Well, if she were alive. Mine's gone too. And joining us is Chuck McPartland, an awesome outreach guy, our Captain Outreach, who's married to Pat, the other Pat, merchandise manager. And Tom Whittemore joins us for a while. Maureen is his wife, former Westmont College science instructor and the editor of our newsletter, the Santa Barbara Astronomical Unit. Tom,
Morning.
just wave goodbye when you're ready to go meet whoever your relatives coming.
Yeah, my nephew.
Which we start the hour with some fun stuff that's sent to us. I call them the silly science cartoons forwarded by President Jerry. We got a plethora of them this past week. Okay, this is the long-haired astronaut coming back. Wow, it'll be great to be back on Earth, and gets off the unit at Earth level, blasted gravity, can't even see. Yeah, like I've seen some of those astronauts upside down inside the space station, and their hair is out to here.
Everyone has an afro up there.
Must be awesome.
Especially if they have some static charge in their hair, it wants to all disappear.
Yeah.
All right, we are at Main Ring and East. What does this mean? Is this an actual place?
This is an actual place. This is the characteristic architecture of the main laboratory at Fermilab,
Right.
where they have the super collider.
Right.
Not the one in Switzerland. This is in Illinois.
Yeah, Batavia, Illinois.
Yeah. And there's a joke sign here: speed limit 300,000 kilometers per second, speed of light.
Very
This
good.
is the main ring road, which runs around the giant ring. And there's no fishing in the main ring.
No fishing in the main ring, and somebody's
Yeah.
bicycles parked there. I think it's amazing that the metric system got almost an even number, 300,000. And
No, science uses the metric system.
oh, it does.
And Ron, they actually defined the meter in terms of wavelengths of light recently to get a really nice round number.
Mhm.
Really?
Mhm.
Well, I keep hearing kilometers or kilometers. That's hard to tell how to pronounce it. Talking stick figures. Planetary scientists are starting to see subsurface oceans everywhere, he says to her in the bedroom. And or no, I guess this is the display on the floor, right? They're about to buy
Yeah,
waterbed.
sales room.
Oh, and this is one of our most popular models. She says, is it a waterbed? No, it's a hybrid foam. Oh no, look at how it moves. I'm pretty sure it's a waterbed. There's a body in it. It was sold by mafiosa. I never mind. That's good stuff. What flat earthers
Mattress
see
life.
on a clear day? Everything.
Pretty good.
Often wondered what it would be like if everything was flat.
Including Middle Earth there.
Is that what that is?
Yeah, that's from The Hobbit.
Well, if humanity goes away, those pyramids will always be there, won't they? Okay, the man's talking to the woman. Are they scientists? He says, our internet provider outsourced their customer service department to the planet Proxima Centauri. They can be here in, 4 years or so if they travel at the speed of light. It's Jeff Bezos' latest Amazon franchise out there. Here's the kid in the hovercraft, and Dad's saying to him, doesn't work, huh? I guess some things just actually are rocket science. Suppose that's Luke Skywalker. Talking heads are talking something. I don't know. Hey, Google. Oh, we're talking to Google. Siri, is that Google? Play us
Yeah,
some.
up here. Yeah.
Okay. The other guy says, why are you being so polite? Well, just in case, he says. And there they are, the talking AI. Keep that one alive. He always
When
said,
the robots have taken over.
yeah. Dr. Phil was all about AI this morning. It's scary and exciting at the same time. Here we go. Coming in. Get my shotgun, mama dang, those aliens are after the chickens again. That's how they get sucked out of the chicken coop. We're back to that one. Okay, thank you for all those forwarded. Can our members get those forwarded cartoons from you if they wanted? Just, I know you send them to Tim Crawford, and he loves them. He's probably on.
No, I think they have to watch here. They are copyright.
Oh,
So I
that's
can't
true.
send them out in printed copy. We can
Well, we
comment
haven't
on
indicated.
things.
Is Tim watching this because he deserves some credit.
Tim forgot and is going to get on late.
Oh, all right, and we're gonna lose Tom Whittemore. We're gonna grab the bread out of the oven. Weird stuff, crazy, cutting edge. As I say, it's not in the textbooks yet. And here we go, ladies and gentlemen. Expand your sight. Get it, fill the screen. What do we got here? Picture of?
This
Globular
is-
clusters.
No,
Yeah,
this is an open cluster.
Oh, I mean, I should just say clusters, yeah.
Clusters are us.
This is a couple of clusters. Let me just go to the next one. This shows both clusters.
NGC 2158 and
Yeah.
M35.
NGC 2158.
Mhm.
The most obscure one is down here. The more famous one and easier to find, but not in this photo, is this diffuse one up here, M35.
You know, there's another cluster in your talking points called the beehive.
We'll get to that later, yeah. Yeah,
Okay,
these are ones that are telescopic.
telescopic. Oh, you gotta,
You
okay.
got to look through a telescope to really see them.
The beehive is naked eye visible if you have a dark sky.
Really?
How did that get in there?
And
We had that experience up at the gun club. It was just coming up. What is
Okay.
that? Yeah.
Okay. Got one out of order there. So this is also NGC 2158.
Mhm.
From processed by an amateur from the Sloan Digital Sky Survey.
I see.
Nice color saturation on it. You can see the surface temperatures of the stars, the hotter stars in blue and the cooler stars in red, and then all of the sun-like stars, whites and yellows and stuff in between, not whites, but yellows. So very pretty cluster.
Well, the cool thing about this is you can look at M35, which is pretty close, a couple of thousand light years away.
Mhm.
And then this NGC 2158 is way in the background.
Right.
Yeah.
It's
And
something like
that's just showing the two clusters together.
Mhm.
So they're just
And that's
countless.
just the very edge of M35 up there.
Mm.
So who's the guy behind the NGCs? I know Messier gave us the M's. What's NGC all about? That's just a separate-
That started with Herschel's catalog and then was expanded.
Right, it's New General Catalog, Ron. New General
Oh,
Catalog.
in 1885, I think, something like that.
Sounds,
and that old Charles Messier missed it, I guess.
Yeah, we would have to call that ultra new for things nowadays or post new.
yeah, 2158 would be hard for Messier to see with his little scope.
Yeah.
Well, I gotta tell you, hosting this program, I'm getting the message that our galaxy is just riddled with clusters. It's like a
Mhm.
raisin bread.
Clusters is a stage in the birth and death of stars, the life cycle of stars. You know, they're born from a cloud of dust, and then stars form in the cloud by gravitational attraction of dust grains to each other. And it runs away and produces stars. The stars turn on and they create solar winds, and it blows all the rest of the dust away. And then you've got a star cluster. And then as the star cluster goes around the center of the galaxy in its orbit, each of the stars is in a separate orbit. So they start drifting away and the cluster breaks up. And like our sun, we started in a cluster like M35 or NGC 2158. But all of our sister stars are now scattered all over the galaxy because that was 5 billion years ago. These clusters are only hundreds of millions of years old.
You know, the
It's
problem I have
not-
is trying to define the word dust. To me, that connotes particles of solid that had to have been created.
Mhm.
As far as I know, the atoms didn't just get together, they get together in stars, don't they? So that the
They
dust
do.
has to be a former star that blew
Two
up.
two atoms of hydrogen. The technically is dust. They're inert. They do react when they get together and form hydrogen molecule H2, but they each have a gravitational field. It's very, very weak, but over a long period of time, hydrogen will, unless it's traveling at high speeds past each other, they will attract and they will stick together. And then now it has twice as much gravity, and so they start sticking together. It's a process.
And Ron, dust usually is referring to small carbon soot type, carbon molecules and silicates that have been barfed off by stars that have made them.
Like there's two or three levels, and we've been created from level 3 of
Populations, they're populations.
yeah, but I'm going to use the word virgin. The initial stuff was all atoms.
It was, but now this is the tricky part in nomenclature. Population 3 is the first stars.
Yeah.
Right.
And they were not just atoms, Ron. They were only atoms of hydrogen and helium.
Yeah.
Really?
And then, as Chuck
The
pointed out,
universe started out with nothing but hydrogen and helium and a tiny amount of lithium and beryllium.
Yeah.
Everything else gets made inside of stars.
Mhm.
I thought the helium had to get made in stars.
No, helium was a large component of the universe too. Not as large as hydrogen. Hydrogen is, 90 something percent, but the rest was mostly helium and then tiny amounts of lithium and beryllium.
We cut you off, Mr. President. What were you contributing there?
No, just I was going to say that, like Chuck said, the particles that come out of later explosions, like carbon and stuff, a lot of molecules are made in those explosions. There's copious amounts of water produced in these explosions too.
Yeah. Wow. Water is a very common, what's the word?
Constituent.
Molecule.
Yeah.
Well,
The word
And
element.
talking about hydrogen burning to helium, this is a opportunistic photo taken in Florida, Sarasota, I think it is. And it shows several of the sun's phenomena with our atmosphere all in the same shot. It's a very lucky shot.
Your notes say a halo and an arc and a sundog.
Yeah.
Mhm.
But can
The
you point it out?
sun dogs are these not nodes out here. The
Okay.
arc is this, and the halo is obviously this. There's another arc up here. These are all produced by different types of ice crystals and droplets in the atmosphere.
There used to be a great website, Atmospheric Optics, that was run by a guy in the UK. And he had pictures and descriptions of all these different arc phenomena, light interacting with water vapor, with ice crystals, with pollen from pine trees. And you get different arcs and sundog type phenomena like this. And you could actually go there and look it up and see what was causing it. But he stopped posting that webpage and it vanished. You have to get it on the Wayback Machine.
The Wayback.
So if you're attentive to atmospheric effects like this and arthritis, you can predict the weather.
Yeah.
That was a joke, folks.
Yeah. Well,
When I was Ted camped in the Arctic, we were doing work in under ice acoustics for the Navy. We would see double suns and see a lot of stuff like this.
well, there's these.
And there's also sun pillars, which is not seen here, but those are bars that go down to the ground.
There's a long list, isn't there, of atmospheric things that
Yes.
happen, like the green flash, rainbows are in the other direction from this. Green flash would mean the sun isn't up. Is the sun up? Is that what we're looking at in the middle?
Yes.
Yeah, that's the sun.
Okay. And it didn't blind us.
So there's also a nice atmospheric effect we frequently do see here, and that is the belt of Venus.
Yeah.
So on a clear day, just as the sun is setting and you look away from where the sun disappeared, you can see a darkness at the horizon, and above it you can see a warmish color, an orangish color, and then you see the blue sky above it. And that dark feature is the Earth's shadow rising up in the atmosphere. And the belt of Venus is the orange band. That's where the sun looks red. And only the red light is getting to that part of the atmosphere. It's being refracted by the Earth's atmosphere.
Right. It's basically, Jerry was on the spot there. I mean, the dark band that you see is caused by the shadow of the Earth into the atmosphere. But what happens is the light comes back to us, and in doing that, the blue is removed, and so it has like a reddish tint to it. It's real pretty. It's sometimes called the girdle of Venus.
Yeah.
Mhm.
But the morning star, Venus, the planet, is part of that? How does
No.
No, that has nothing to do with the
Nothing to
planet.
do. It's an effect of sunlight.
I
Sun
got-
basically being modulated by our atmosphere, or the ball of the Earth actually casts a wonderful shadow. We see it all the time here at the house.
And the zodiac light is a spike into the sky, isn't it?
Yeah.
Kind of.
Mhm.
Okay, we're going back to the night sky with Jerry and the gang. What?
Yes.
Give me the title or the.
This is the
topic.
southern sky.
Mhm.
And let's see if I lost it here.
Yeah, there's M30 in Capricorn.
Yep, there's a lot of features here. This is 5 in the morning. This is looking due south, and this is the star Fomolo. It's a southern star. And if you have a good south horizon, the McDonald Observatory has a little radio blurbs that they send out, they syndicate. And in there, they refer to the brief visibility of Fomolo as the Fomolo hour. Because you don't get to see it much of the year, but this time of year you can see it deeply in the south.
Yeah.
Now this is showing the location of it because the James Webb has taken a picture of Fomolo. And the
And
dust
actually,
cloud.
Jerry, if I can interrupt, Fomalhaut actually comes high enough that it's visible a fair amount of time here, but by Fomalhaut hour, I think they mean when it's at the zenith at midnight.
Right.
Yeah. Yeah, I think it has about an 8-hour arc, Jerry.
Yeah.
Something here.
Instead of.
Yeah, I didn't mean that it was only up for an hour. I guess that wasn't clear.
Yeah.
So anyway, but where I was as a kid, we had a poor south horizon. So one time I think I spotted it through a notch in a hill. So that was literally an hour.
I think you're thinking of Canopus, aren't you? Because
Canopus.
Because
Yes.
Fomalhaut is pretty high here,
Right, it's pretty high.
California.
Whereas Canopus is only visible here. We see it from the house. Maybe 5-hour arc.
Yeah, and
Somewhat-
very
okay.
low toward the islands out there.
Very low, very low.
Yeah.
And it's
So
gone
anyway,
now.
the takeaway here is it's low in the south.
Yeah.
Yeah.
But is it
So-
a star with, it's a star with rings, not planets?
This is it.
We don't know about planets for sure, but it
Yeah.
definitely has asteroid belt here.
Right here, this is taken as either a planet or a protoplanet.
Wow.
That's in one of the rings, and that's dust rings, dust clouds. It's formed.
The length of this line here is 80 AU, and that should be applied along here because it's foreshortened here.
Mhm.
So this is about 80, 160. So this is about 300 astronomical units across. It's like our Kuiper belt,
Mhm.
or the
Why
outer
did-
edge. Is.
Why is there a big black spot in the middle of it?
That's blocking
That
out
is
the
be-
starlight.
They're just blocking it, Ron.
Yeah,
Oh, okay, that's where the sun is, or it's stellar? Okay,
this is it's a star surrounded by a dust disk with certain areas being cleaned out because stars are forming in it.
wow.
So James West has the ability to run something in and block the bright light.
The James Webb must have an occulting disk of some kind.
Yeah.
It's up there in Pisces. Wow.
Actually, it's in Pisces Austrinus, Ron, not Pisces.
Right. That's right. Yeah, the southern fish.
Really? Okay. I want to explain that at the next pre-program Gladwin Planetarium show to us.
Well, it's a whole separate constellation.
Right.
Oh, I didn't realize that.
Yeah, it's a very lonely part of the sky too. You know, Fomalhaut just doesn't have many friends out there.
Yeah, it's the only first magnitude star in that part of the sky.
Oh, okay, so it's seeable by the naked eye.
Yeah.
I gotta get some clothes on my eyes. This is
Oh,
nakedness is cold. Okay.
so at 5 a.m, this is not a lot of stuff down there.
Anybody know who astronomer Fomalhaut was, for whom it's named?
It's an Arabic phrase for mouth of the fish.
Right.
Of course, I knew that. Yeah, right. Okay. Love the night sky. When we can see it.
Yeah,
Did you see anything Saturday night, or was it totally a blitz with your
It-
50 people showing
It
up?
was obliterated.
Oh, well,
You
Came
could
up-
barely see the light on the top of the monastery or the seminary.
the
Huh.
bane of the astronomer, the telescope people. Where are we now? What's this?
sorry for the sneezing fit here.
This is
a
Mars.
U.S. Geological Survey map of a part of Mars where Jezero crater is. This is Jezero crater around here, and that's where Perseverance rover is working on this delta here. And this is new evidence. It's included in the map. There's a river here.
Oh,
It kind of meanders like the Mississippi River.
Wow.
Parts of it are cut off. There's other parts that have flows, and they're identifying through Perseverance is down in this region, looking at the delta and the mouth of the river. And it's finding, this is a picture, a mosaic, and you can see that there's a large number of small square pictures put together to get this mosaic. There are patterns that you can see from orbit of these patterns of striations that they look like they were produced by, according to geologists, I'm not a geologist, but this is evidence of a rapid flowing river, this type of structure. And you also get features like sandbars and stuff, and these islands produced in the flow, where the flow has carried away this material but left more rigid stuff up as isolated islands. And this is the type of features that they're seeing from orbit and from Perseverance. So the conclusion is now that it's very likely that this was the region of a reef, but very rapid reef on a geologic scale, but a very rapid river that flowed very forcefully in to fill up the Lake Jezero.
Oh, it filled up Jezero, so it was heading into the canyon. They know the direction it was flowing.
Yeah, this is the crater which predates the water flow or comes at the same time as it. And so the water flow came from up in this area, and you can see that it's building, it's getting stronger as it gets closer to the crater. So it's picking up this watershed up here and flowing it out. And this is a delta into the lake because Jezero crater was once a lake.
Wow. So they didn't have, there were no oceans on Mars, just big crater lakes.
There may have been oceans in the southern hemisphere.
Oh, well, what's the sprinkle haven comment? You put that term in there. What is called sprinkle haven? They named it already.
It's not sprinkle, it's a K, it's sprinkle. And it's these geologists name them after features. And so this is the area of Sprinkle Haven. I think that's the one, or is
I wrote the word right from your talking points, Jerry. Sprinkle.
yeah, it's in there. It's in there. I just want to get it.
It's
SK
SKI
though, Ron, not SP.
Yeah.
Oh,
Yeah, this is this is Pine Stand, and this one is the one labeled Sprinkle Haven.
okay.
Sprinkle Haven, yeah.
Okay. Why do you suppose we have the black on there? That's part didn't photograph?
Yeah.
That's probably pieces of the rover that they cut out that would have been in the image.
Oh, I see. Got it. Okay. Interesting. So those aren't strata.
They are.
Yeah, they are.
Well, they are strata.
Yeah.
Normally, I don't see strata laying on its side like that on the Earth, but maybe just indicates water went.
You do,
No,
where
these
there's
are
been tectonic motion.
Really?
These are the remnants of sandbars that formed in the river. This is all sandstone.
Oh, wow. And it all evaporated into space except what's left as ice somewhere.
Well, some of it probably evaporated into space. A lot of the gases did. The water is apparently still in Mars. It's down in the land and under the land.
Well, they're going to see what they can extricate on the moon. So that'll be a dress rehearsal for getting water when they land on Mars.
Yes.
Huh. I heard that the spaceship that goes to Mars will need to have a circular amount of water around the whole cabin they're in to keep the radiation out. Have you heard that? Water will absorb
Water is a good shield, yeah.
Yeah.
from the rays of the sun, solar wind.
Well, rays of the sun and from deep space. Cosmic rays don't all come from the sun.
Oh, okay.
But yeah, water is a good shield. Dirt is a good shield, but water's, and that's for in the spaceship on the way.
Yeah.
Have a double hull and put it around there, or some other, or they might do what they do on the space station, the International Space Station. They have one room that has extra thick shielding, and when they get a solar flare or they feel the astronauts are in danger, they have them all retreat to this safe room.
Really? And
Certain-
protected by water.
Yeah, certain plastics are good too. And so you can line it with that, with a thick layer of it.
Mhm.
That's all we need to do is now put plastic out there and that debris field far out. Remember that phrase? Far out. New stuff from Perseverance. And I can remember when all you saw was flat on Mars, in the early pictures, Voyagers and other.
Oh yeah, those were just from I
Yeah.
think Ranger was the first thing to land. Oh, that was landing on the moon.
Yeah, right. But everything was flat. Now they're going to take chances and land in craters and places near mountains and mons and things like that.
You got to go where the interest is. They're looking for life. You got to go where the water was.
Well, plus you got to go to a place where it won't fall over or crash on rocks. It's going to be.
That's a big problem with, in my mind, and I haven't seen it discussed very much, but Elon Musk's recent attempt to launch his Starship, it basically destroyed the stand that it took off from, created a big hole underneath. When something lands on Mars, it's not on a prepared landing pad. It's not on an airport or on a ship at sea. It's going to land on sand and dust and rock, and it's going to splash that stuff all over the place. And you can't guarantee it'll set down on a flat place. So I think they're going to have to, this is my speculation, they're going to have to send robots up there to make a paved area or a reinforced pad or something to land on.
Well, you think they'll land them with parachutes or bouncing balls of helium?
No, I think they're going to land with turn the rocket face up and land on their jets like they do, like they recover the boosters here on Earth.
I gotcha. So what
But
is
they're
this is that just a mountain we were looking at, or is that a former volcano?
No, this is a large sand dune. This was in the river that formed because this was a slightly harder material than the sand down here that got blown away or washed away. And then these sand dunes here, these are wind produced.
That
But
sucker looks.
this is a midstream island that was left.
Oh, okay, it's big. It's like looking
Yes,
at-
I don't know where it is exactly on this map. It's probably way too small a feature on this scale. But these are in the flow of water.
all those colors have meaning on that map, don't they?
Yes, they do. And the legend is not here, so.
It's probably mineral types.
Yeah,
And depth, yeah.
But upper right would be considered Jezero crater.
Yeah, here's the word Jezero.
Oh, there it is. Yeah,
And
Jezero.
so this is the crater that's Jezero. This
Wow.
is Nili Planum, Nili Planum. And I
Okay.
don't see any other words up here. So
Fascinating. What is this?
this is a retroreflector, an array of corner cubes that was left on the moon by Apollo 15. This is on the moon. You can see the characteristic space boot print. Now, a single corner cube, which is at the bottom of each one of these circular apertures, is a feature of glass in the shape of a cube that when you shine light directly into it, it sends it back in exactly the same direction it came from.
Mhm.
So we can send the laser beam to this on Earth and we get a return beam from it. And you can measure the distance between your laser on Earth and this array on the moon. You can measure it to within a fraction of a centimeter. So it gives you a very accurate motion or a readout of where the moon is relative to the Earth. You can get every little wiggle and twist of it, not twist, but every little wiggle of its radius from Earth as it orbits the Earth.
And you see these things, Ron, these corner reflectors. Those are the little metal things that they raise up on the masts of sailboats to make them show up better on radar.
Right.
oh, yeah.
And they embed these in the paint that's on highways and on street signs. So they're highly reflective when your headlights hit them.
Well, also the round reflectors that are on all the signposts along the freeway are made from
Yeah.
array of these.
Mhm.
So
So
hard to
this-
tell how big that sucker was.
You see the boot print there next to it.
Oh,
Like
Yeah, see, here's a footprint right there.
oh, I see. There you go. That'll show.
Yeah.
And those things on the top part of it, is that like a step stool or what?
There's a stand for it, and then there are some other instruments there.
Yeah. This
Yeah,
looks like something that's like the equivalent of a sundial.
Yeah,
So
yeah, you're
this-
right.
Produces a shadow, and this is a handle, and there's a handle.
That sundial bit was probably so they could orient this thing so it was very accurately pointed toward the Earth.
Yeah,
And did you tell us which Apollo flight did that?
15. This one was from 15,
15.
but these are the sites from Apollo 11, 15, or 11, 14, 15, 17, and 21.
Well, the 17 and 21 are lunar.
Yeah,
Those are
that's right.
Russian ones.
Oh, yeah, all right. There's an L there.
Yeah.
So only 3 of our Apollo, they did 5 or 6, didn't they?
The 5 or 6 landings, but only 3 of them, I think, left corner cubes, or those are the corner cubes that are working.
And they left a rover, a driving vehicle that,
A couple, yeah,
and there's a golf ball up there.
at least one.
Somewhere or in orbit.
In orbit, yeah.
Now, when you can measure things, you put spacecraft in orbit. The moon is not spherically symmetric. It's got mass distributions in it, so that are not give it a non-uniform thing. You can probe these things. You can figure out from the distortions in your orbit and from fluctuations in the distance between the Earth and the moon as it orbits. You get really detailed orbital plans like that. You can back out of it the mass distribution in the moon. And so from that and seismometer data, they have decided that the moon has a small iron core, and outside of the core, at its outer core, the layer down here, that's liquid, probably magma. And this is solid iron core here. And the rest of this is mantle. The moon is mostly mantle. It's mostly earth mantle. And that's what has led to the speculation that the moon's origin was likely something equivalent to the big splat or the collision with another planet called Theia. And because most of the moon is made out of mantle of the Earth. The composition is identical as they bring it back. They brought samples back.
Would they be able to tell how deep that magma is?
Yeah.
Yeah.
I mean,
Yeah, this is a scale drawing compared to the moon's radius.
okay, well, where's the magma in that scale?
The white.
This white.
Oh, it's way down there.
Yeah, that's the liquid outer core. This is the moon's mantle, and this is the moon's inner core.
Okay, too
Which I
far
think is-
down to give us moon volcanoes then, isn't it?
The moon volcanoes were a feature of the past or occurred when something hit it and created a local magma chamber.
And obviously there's no plate tectonics. Nothing's moving on the surface, right?
No,
Wow.
the moon, current moon mysteries that they're trying to solve is why the moon once had a magnetic field that was 100 times stronger than Earth's is today. So about 100 Gauss.
Well, doesn't that require movement of the insides?
It requires some kind of dynamo effect, yes.
Certainly happens in the sun, doesn't it?
The sun has a sort of a chaotic magnetic field. That's what gets twisted up and bent and distorted and produces sunspots and solar flares and stuff.
100 times Earth's magnetic field would be about 50 Gauss,
Okay,
or a half a Gauss.
within 50, within a factor of 2, that's scientifically acceptable.
Well, I got to
So-
tell you, gentlemen, if our moon was created, you said there was a name for that large body. It was a planet or a
Yeah.
dwarf planet that hit the Earth.
Was about the size of Mars, they're estimating, and they gave it the name Theia.
Okay, that's something you've never seen a picture of. Two things, as far as I'm concerned, that you know that I know that comet that broke up and landed on Jupiter is considered that, but it's not like the drawings you see or the versions of two large bodies. I had to be a long
Well,
time.
there's a lot of animations, speculations of how that would have looked, but of course there are no actual pictures.
Can't imagine it, but all the reorganizing of the iron going to the middle and
No, in detail, when they hit, they produced, apparently, according to one lady's calculations, they produced, and I forgot the name of it. but it's a
Synestia.
feature a what?
A synestia.
Yes, that's it. It's basically a torus of dust. Just the whole structure was not uniformly distributed, but it was this giant torus of debris, and it collapsed back to the Earth and some of it to the moon.
And the speculation was multiple moons, actually, smaller and bigger ones. And it's a partial explanation for why the crust on the far side of the moon that we don't normally see is much thicker, but much less dense than the side that we do see, is that another smaller moonlet collided with the moon at low speed because they were co-orbital, basically, and formed that coating on the other side.
Well, do they have the timeline in place? The solar system itself is what, 4.5 billion years old, about a third of the age of the universe itself.
And they're talking here about like 4.2 billion.
Of just
Years
the
ago.
the moon and the earth, what's left that became the earth had to reorganize and resettle, and
Yeah.
that took
Yeah.
billions of years.
But it's got plenty of mass to pull itself into a sphere.
Wow. And it's going away, isn't it? Slightly. It's not coming in.
Slowly.
Moon's orbit is slowly leaving us.
Yes.
Yes, about the width of a hand per year, roughly.
Just like you said.
It's about an inch, a little over an inch a year.
Okay.
Wow. Just amazing. So there's a little bit more outward thrust or movement on its. If it slowed down just a little, we'd keep it forever, wouldn't we?
Well, that's the interaction with the tides on the earth that's doing that.
Right, right.
Well, it loses energy to the tides.
Actually, it's gaining angular momentum from the tides.
Really?
Yeah,
I
the
thought
earth,
the tides flowing over the earth that, it takes energy.
right, and that's slowing down the earth's rotation. But the earth rotates faster than the moon revolves around the earth. So the bulge ends up a little bit ahead of the moon and pulls on it and speeds it up in its orbit.
Okay. So it goes further away then.
Yeah.
Yeah.
Have you ever wondered, gentlemen, if those huge oversized seas that are landlocked like Caspian and the Black Sea, do they have tides? Can you see them at all?
Sure.
Oh, yeah.
There are tides in the earth itself, Ron.
Right.
The ground actually raises and lowers.
Right.
And that triggers earthquakes.
Well, in the Black Sea or the Caspian, something big like that, where would it go when it's low tide, and where does it come from when it's high tide?
It sloshes to one side or the other.
Yeah, your boats rise up with it.
Oh, okay. Thank you for the question there.
Yeah, Ron, the fact that the earth is also affected, not just the oceans and stuff, was noticed in the early 1900s when they were laying down the subway system in Chicago. And they noticed this. They noticed that when the moon was in certain positions, their precision instruments, would be a little out of whack. Pretty interesting.
Mm-hmm.
So it just doesn't always pull on water. It pulls on the structure of the earth too.
Well, it has nothing to do with the slight bulge. That's our centrifugal by turning the earth itself, right? Or is that a combination? Yeah. There's a bulge at the equator, right?
Yeah.
We don't. Our Earth is mostly there's the sphere, and then the next harmonic up is a n equals 3, which makes it look like sign of a pear.
Yeah, that I don't understand. I'm sorry.
The harmonics are 1, 3, and 11 to get an accurate distribution of the gravitational field due to mass of the Earth.
Wow. Now, president of the club, Jerry Wilson, has put on the screen 3 views of something that we, I guess, mislabeled. Science did
we did the first a few month ago or so. This photograph was taken with, I think it was Hubble, and it was interpreted as a black hole moving at 200,000 miles per hour away from a galaxy, which was over here, and it was carrying a wake of dust and star formation behind it. But other teams have published papers that refute that and claim that what we're looking at, because of the environments and the spectral distribution of the light, that what we've got is a case of a lenticular. We're actually looking at a galaxy edge on, and it's a galaxy that does not have a central bulge. And here's 2 examples of galaxies that are used to compare to this one.
I think that's the same one, but the middle one is ultraviolet and the bottom one's visible.
Bottom one has
but these are not this.
Right.
Yeah, no.
Really? They're not all the same thing we're looking at in different views?
No.
These are comparison of the kind of galaxy they think this is.
Oh, it's not the same one. I misunderstood. So the middle one and the bottom one are the same galaxy.
Right. Yeah.
Edge on. The bottom one does seem to have a little bit of a whoops, we lost it.
No.
Seem to have a little bulge in there, wouldn't you think?
Yeah, a little bit.
Teeny.
Hmm.
So
Looks
it's
like there's a
still,
ripple going through the upper one,
Yeah.
vertical.
Yeah. And the visible light photo looks a little different, and you see that little bulge, but the other two are both ultraviolet images, and so you can see the comparison better.
now this was a little out of order, but this is this was the first interpretation of a few months ago. A black hole streaming out of this galaxy and pulling dust and gas out behind it. But the dynamics of that do not fit the environment that is measured around here. This is an artist drawing too. So now it's believed to be this situation. This is an actual photograph of whatever it is.
From Hubble. Huh.
I believe it's from Hubble. Let me look.
Yes, it was from Hubble.
Yeah.
How far we are looking there? It's got to be a long way away.
Yep.
Okay. Are there any other examples of that sort of thing happening? A black hole runaway road
No,
taking
that would have
everybody with
been
it?
that would have been a unique find,
Okay, wow.
an itinerant black hole.
But edge-on galaxies like the middle and bottom one are rare.
Yes, they're not that
Um,
common. They have to line up very precisely for us to see them that narrow.
What do you think that purple star is there over on the right?
Have no idea.
Huh, it's circled.
It looks like they're trying to show a strong knot of ultraviolet there that you see in the one above, but
Yeah, maybe.
Oh, yeah.
Well,
Okay.
when you guys see the Milky Way in the night sky at its big angle, it doesn't really look symmetrical much at all. It's just a godly collection.
No, but we have large central bulge.
I know, but we don't see it.
Yeah, we
sure
do.
we do. That's the summertime Milky Way. That's
Yeah,
why it's so
it's
big and
really-
bright.
It's really wide. Matter of fact, I think we have a picture of it here.
You actually can't see the middle because of the dust between us and the middle.
Yeah, there. You
There
just
it
went
is.
past. Yeah, there it is.
See, there's our central bulge, and here's the rest of our galaxy out here without the central bulge, but this is a biggie for us.
It's a
And
real
right in
picture.
the middle of all this thing, that's Sagittarius A star.
There's
they-
pipe nebula too. See the pipe,
Can
Yeah.
Australia see that?
the pipe
They get it
nebula. just
overhead.
below Jerry's his arrow.
Right here.
Yeah, that's
Oh.
the end of the pipe. Then yeah, that's it. Very beautiful. Mhm.
So our young speaker from UCSB, they had radio telescope viewing in right through that to get.
Yeah, a lot of dust and clouds of dust and stars in the way.
We're out here in an arm. Would this be what it looked like if we were in an arm and not in a spur?
That's what yes, and we are in an arm, and that's what it looks like.
I thought we were in between the arms in a.
Well, we're in a small arm.
Okay.
Yeah, people have been going back and forth about whether we're in an arm or not. So
Well, they got a name for it. It's called the Orion Spur.
yeah, or the Orion arm, depending on who you talk to. So
But most spiral galaxies have two big arms, don't they? That are mirror images of each other. Or
two
are there
to four.
2 or 4. That's an interesting thing.
I sent you guys a video of galaxies and the galaxy structure. And the reason it was because the Baron had asked last week or the week before which way the galaxy spins. And in there, they show galaxies that are measured to spin both ways.
Yeah.
Some of them with the arms leading and some of them with the arms trailing. And they
And
point
some
out
of them
that
with
the
parts
arm-
of the galaxy going one way and other parts going the other way.
Right.
Boy, I can't see it.
Did you-
It's
Did
because
look
they're
at
not
the-
physical structures, Ron. They're like
Yeah.
traffic jams.
Do you did you look at the video?
I did. It was very good.
Yeah.
I try to, everything you send me, I try to open up. Sometimes it's gobbledygook, it's computer.
Yes, sometimes I get this weird NHN thing and I don't notice it. If I notice it, I copy it so you can see it.
Yeah, PHP. Yeah.
But I mean,
So anyway, this is up there because of a very interesting article that The Milky Way's own dynamics may sabotage habitable planetary systems. There's a study that was produced that says that, and I went back and forth about this one because it refers to phase space. And while an engineering firm, you really usually refers to someone that's, inside his mind thinking and not paying attention to anyone, oh, he's in phase space. But there is really a phase space, and it's the mathematical term for plotting both position and momentum at the same time on a plot, a two-dimensional plot. So the dynamic, they plot this various parts of the galaxy in phase space, and when there's overdensity, as they call it, that is, the things are both a lot of things there, and they're moving at different speeds, not all together as a unit. That's very hostile to habitable planet formations because there's collisions, there's close by motion of other stars that throw this, that break up planetary systems and cause a star to lose its planets. And so regions of the galaxy where it's very under dense in phase space, that's where we are. And that's where most habitable planets are likely to form, according to this study. It's a statistical analysis. Phase space is a technique in statistics and statistical physics. So this shows the region of our sun with regard to local clouds of dust and a few stars. And this is largely, there's a lot of stars missing here too, of course, too. But we don't have a situation like that. We are in a denser region spatially, but we're not in a chaotic thing where all stars are moving like a beehive, all buzzing around each other, like in a globular cluster. So a habitable planet in a globular cluster is just right out. So the purpose of this is that, or the end result is that we should be looking in these phase space bubbles for life on other, evidence of life on other planets.
Somewhat related is an article I just saw where they redid the Urey Miller experiment, and that's the one where they took a simulated early Earth atmosphere and they exposed it to heat and electrical discharges to mimic lightning like you might have had on the early Earth.
Right.
And they produced some amino acids. That was a real famous experiment.
Mhm.
But they recently redid it with, I think it was in Japan, where the researcher had access to a particle accelerator. And they redid it, simulating, instead of just heat, lightning, and high-speed protons like you would have gotten when the sun earlier in its lifetime was more active and you had more large coronal mass ejections and flares. And so they bombarded that same mixture of ammonia and methane and so on and so forth from the early atmosphere, also with these high-speed protons, and they formed many, many more amino acid products and precursors to life. So they think that actually having an active young star might help in giving rise to sort of biotic materials.
So it's looking bad for Alpha Centauri.
No,
Yeah.
it actually looks a little better in some cases
Oh,
as far as producing these more biotic compounds. And then when it calms down, then you get the chance for an actual life to not get bombarded with this stuff, but it has the raw materials.
Ron, it just goes to show you that it's an amino world.
Well, isn't the key to the whole thing? We pretty much all agree that there's got to be a Goldilocks zone, where things could be habitable. Are there less of those?
That's with regard to temperature producing liquid water only. That's the only parameter due to the Goldilocks zone. There are other things that you have to have that make it more complicated.
Yeah, they seem to be finding a lot of super Jupiters, super hot, that are close into their stars. I mean, nothing could survive that, or I don't think life.
Those are examples of what happens in overdensity phase space areas, where massive Jupiters that get produced, first of all, in areas where there's higher over density, you get single planet solar systems. There's not multiple planets, because a lot of the planets have been stripped off by neighboring stars passing close. And the neighboring stars have also caused the real dense planets to move in closer and eventually merge with the star. And so when you find hot Jupiters, you're not going to find multiple stars, the multiple planets there, and unlikely to find habitable planets there. That's the result of their study.
Here's what your notes say. So far, NASA has confirmed 5,200 extrasolar planets, but determining only about a third of the stars out there have planets. The rest of them just form a ball and kick in nuclear fusion.
That means that no, the planets are hard to find. Doesn't mean that they don't have planets. They might have no planets, but it means that planets the size of Earth, they just haven't detected yet. I saw that point in there. I wasn't too impressed with it.
Who's the name of what's the name of the guy that has the formula for life?
Drake.
Okay, there's the Drake equation, and then there's the Fermi paradox. He simply asks, why aren't we finding them?
Yeah, where are they?
Where are they? The Drake equation is based on our life, right? Amino acids, every so often they come in on a meteor, don't they?
Yeah, find them in meteors.
Yeah, I was gonna say, Tim Ferriss has a really neat video he did many years ago about the Fermi paradox. And what he does is he sets up a table, okay, and he's sitting at the table, and then there's another chair at the table, and he's sitting there waiting for, you know, some alien to show up. Actually, he puts out lobster, beautiful lobster dish, and of course, nobody shows up.
There's some crazy scientist that thinks that octopuses, or it used to be octopi, are extraterrestrial. They're so smart, so different, and they live in the ocean, and maybe they spawned us all. You know, it came from outer space. Octopus.
Yeah, it's another nice video called My Teacher, the Octopus.
Oh, that's a great film. I saw that.
Fantastic. Yeah.
It's trying to make the point that octopi are sentient.
Yes.
Or what?
Sentient.
Yeah, the fellow actually
befriends
an octopus.
Are you saying sent here?
No, sentient. Yeah.
Sentient. What is that? I don't understand.
They have consciousness, and they have an appreciation of their own existence. And,
right.
Well, they're certainly underrated.
Yeah.
You know, I took an octopus down in the trunk of my car to Cal Worthington to give him an 8-legged dog spot once.
I'm gonna have to say goodbye, you guys.
No, is it something we said, Tom?
No. My nephew is here.
Well,
you held out till the last 3 minutes.
Yeah, telling me timed it just right. So we're down to the wire. Anything you guys want to recap at the end here?
Yeah.
We got time to go to another
second.
Mars we did Mars.
No, we're gonna do this Mars.
Ophiuchus?
No, we're gonna do this Mars.
Aha.
And the beehive.
In the beehive. Here Mars is in the beehive, and the date is June 1 at 10 p.m. So tonight, Mars is way down. Of course, the whole thing is higher up because this is in the west, and every day these get a little lower at that time. So the beehive is up here, and Mars is about here, and they're coming together. And Mars actually enters the beehive the last day of May or the first day of June. So this is going to be some great photographs if you take pictures, and it doesn't require a lot of magnification.
Beehive is known as M44. It's another cluster.
Yes, this is the beehive. It's a open cluster, and it's very close to us. So it spans. It's a big cluster, and easy to the naked eye.
The ancient Greeks used it to predict the weather. If you could see it, it wasn't going to rain the next day.
Okay, are they all?
That's pretty much true. Yes, that's
right. I guess I would say there's more variable stars than there are clusters, but lately all we've been getting is a lot of clusters on this program, gentlemen.
Everything started in a cluster.
I hadn't thought of that.
Is the beehive that upside down V in the middle?
Some people interpret that as, an old style conical beehive.
Right.
Yeah.
Well, I can think of busier looking star clusters than that one to call a beehive. There's not much to that one. The hive has only got a couple dozen stars, or that's just the brighter ones.
That's just the brighter ones.
Yeah, here, we're turning it this way. This orients the beehive part. And these are the bees.
And it's the fault of your mirror that gives us the 4 points on each one of them. That's how
It's not a fault in the mirror. It's the structure that holds the secondary mirror.
Yeah.
Oh.
I met a guy at CalStar that was imaging things with a refractor, and he had fish line stretched as an X across the front of his telescope to give the spikes on the stars.
Not
So-
crosshairs on a rifle scope.
It's like that, yes.
That will do it.
Oh, okay. I think we've run out of time, gentlemen, but this is awesome. Anything coming up real fast here, Mr. Outreach?
Well, tomorrow morning is Westmont with a solar for applied or advanced physics classes at I believe it was Santa Barbara Junior High.
Aha. How about you, Mr. Theater Organ Society? You guys gonna take the organ out of the stage there at Arlington anytime soon? And
We did last Saturday. We had an open console. It's typically the second Saturday of the month.
amazing that you got all those things going for you, Bruce. And took care of our moms, those of us that are married to moms, and we'll see you again next week. I guess we got no business meetings online, and that's done. That's behind us.
Mhm.
For the
And we're gonna
month.
welcome Dr. Antonucci on the 2nd of June, and plus
Yeah.
maybe another huge crowd. All right, take care of everybody, yourselves included, and don't catch any COVID left